So thanks again for giving us some minutes to give you some very early insights into some of the work we are doing in Norway. And as you know, KNOWIT is defined as within the knowledge industry. So that's kind of our case and the frame around this. But my hope is that these insights can be of inspiration. I hope to have some questions and discussions. I hope that people in other industries maybe see how this can be relevant. I would like to discuss that. And I think it's in the spirit of the project to do that. So, and this is an attempt of that. So, I will give some part of the presentation, and then Jan Henrik will show some of the work they are doing in the inside of KNOWIT. And we'll try to bring together the results. And actually, we are trying to use the framework, as you will see. I'm very excited about that. So the context here is knowledge work. That's what KNOWIT is producing. They produce knowledge. And knowledge workers can be of many types. So it can be engineers, scientists, medical doctors, software developers, and so on and so on. And I guess in this room there are many persons that could define themselves as knowledge workers. And the main capital for knowledge workers are knowledge which is used to make the products, which then is applied to the physical world. So like software systems or control systems, there are millions of examples, and we are all users every day. Software developers, which are the kind of workers that we have studied, have to relate to many forms of knowledge in their job on a daily basis. So they need to have knowledge about the domain they are working in. It can be medical systems, the problem they're trying to solve, the people they work with, the processes they need to follow to work with them, to work with the end users. They need to have knowledge about the data, and so on and so on. So it's a very knowledge-intensive type of work. And the result in many cases is software, which is codified knowledge. And by the way, I'm giving a kind of a very high-level introduction here. I know there are people in the room that learned this in kindergarten, but I'm trying to start with a very high-level view of this. So they produce the result of their work, of their knowledge work, is software. And software can actually be considered as data itself. And this has made it to a huge case related to generative AI. And that's the frame of the studies we have done, because generative AI has become, I would say, a paradigm shift in the software engineering domain, as you all know. So that's kind of the frame of the studies we are working on. And just a brief introduction about AI and generative AI and large language models. This is about building neural networks, very much inspired by how humans learn. So this baby is looking at an apple, and the mother is saying the word apple. And this is repeated many times. Learning happens, and neurons in the brain connect in a way that makes this baby learn that this is an apple. And if the baby learns about an orange, it will be able to tell the difference. So it's a learning process connecting neurons in the brain. Likewise, when we build AI models, we try to mimic the neural network. We try to learn the neural network. It's not programmed. It's not any human that has written the rules. We give it a lot of data, a lot of input, and then it automatically learns, very much in the same way as the human brain. And this is a very quick example. So this is output from for instance, ChatGPT. And the bold text is the prompt. So that's the input we give to the model, expecting an output. If the model is not trained, it will just give a random collection of characters. And we all see that this doesn't look anything like something a trained human being would provide as a continuation of the prompt. However, in this case, we have taken the authorship of Jane Austen and given it to the model and trained it 250 repetitions. And what we see happening here is that it kind of understands which characters that are not related to human language. It's taken away. We see structure of words, but it's totally nonsense. So we keep on training because we have the machine power. And here we see that it has learned more or less what are normal English words, but still there's not much meaning into this. But if we repeat the learning process enough, you will see that it can generate text that is readable, it has a meaning, and it's generated. And it's fully based on the learning from a sample set of data, in this case, the books by Jane Austen. And likewise, we can train models with large code samples from GitHub repositories, for instance, and it will learn how programming languages look like. The syntax will be more or less right, and so on. So this is what happens when these models are trained or built. And I guess everyone in this room are users of these models, writing job applications and love letters and stuff like that. And the last message in this, or the second last message in this very quick introduction, is that language models are only that. Only language models. They are not knowledge models. So they really don't contain any new knowledge. They cannot understand new knowledge, develop new knowledge. It only produces text. But if the text is trained on input containing knowledge, it can bring knowledge forward. But it's reason for being very cautious using the output from these models. So still the human need to be there to understand what's the output and to see whether this makes sense and so on. So it's a huge warning. And I think a lot of people are kind of over-optimistic about this. And AI is a huge field. It has been around since the, I don't know, the 70s. But for the last couple of years, it has kind of come to our attention, everyone. And what we are talking about now is the large language model part and the chatbots. So that's the focus of the rest of the story. Okay, so we have chatbot assistants, can be used for anything. Because it's language, so it can be very flexible, many use cases. Models can also be trained on images, huge amount of images, and likewise, putting a textual prompt input, we can have amazing images as an output. Just the same way as it produces text, it can be trained on images and also produce images. It can produce very good, amazing videos. We're not doing the cinema, so I'm not playing the movie. There's a lot of examples on YouTube. And also, it can be used to generate 3D models. This is an example. A colleague of mine, he designed this dragon as a 3D model using some models, specially designed for that. And he printed the dragon on a 3D printer. So that's one use case. What's interesting for our industry mostly is software. And there are tools like GitHub Copilot. ChatGPT is also a very good coder. So these are extensively used to produce code, very much to produce boilerplate code. It can be used to change code. It can be used to test code. So it's like it's an assistant for the developer, very much in use. Okay, so this brings us to the research that we have done. So we have done 2 studies. We have entered a lot of organizations. Many of them are working with KNOWIT and is their clients, because KNOWIT is a knowledge, it's a consultancy company. And we have studied here how, we've been looking for the early experience from the workers themselves, how they they see the use of generative AI as a tool, how it influences their work. And this is starting to be relevant for this project. So we've been looking into how it's influenced the affective experience of developers. That's one study. And the other is, in general, how does this affect their relation with the technology in their workplace. And this is a very explorative study. We have to start in that way to learn what is happening out there. So it's really hard to define any specific research questions. So we are starting to talk to a lot of people, software developers, some engineers, and looking for their experience on this to see what emerges from this huge experiment, which it actually is. So we've done a lot of semi-structured interviews, recorded, it's transcribed, actually using a model called Whisper, so using AI to transcribe. It actually works very, very well. Even Norwegian is translated and transcribed very good. We've done a thematic analysis of this to find some trends in the data material.
So, in KNOWIT, we also have AI lab, where we try to experiment a little bit. So, what Geir told you about was this use cases where our consultants are at the customer site and doing development, but we also have other tasks inside KNOWIT. Our job is to sell consultants. So what we have designed is a CV role measure. So that means that we take a bid, people ask for a consultant, and they have some demands for that consultant, and we use AI to compare this with all the consultants in the company, and that's 4,000 of them. And then we automatically match and score these consultants. But the research Geir and the researchers are doing are actually trying to see how this affects the sales people. How do they use this in their daily work? So this is changing the way people are doing their job, and this is one example of that. And we also do this in other areas like competence. We obviously have to have to know what our people are actually knowing, what competences they have. So we use AI to structure these better than we've done before. Okay. So this is one example of what we're doing internally. We don't have any results from this yet, but this is coming.
So thank you, Jan Henrik. And this is, I think it's a brilliant example of trying to master large amounts of unstructured data. You know, CVs are in many forms. People use different terms for their knowledge and competency and experience. And likewise, the bids that you are working on, there's a lot of text. There's a lot of work to see what is really the content of this. And using AI to bring this together as a tool, it's really exciting. So we look forward to look more into that. Okay, so I took the liberty to use this brilliant framework to see where can we find how can we place the lessons learned we have from the data material within the framework. And what we see is that we have some findings relating to employee satisfaction. So people or developers actually report some kind of affection to the tool. They find it inspiring. They find it actually fun and stress reducing. That's what they tell us. We haven't measured the stress among the developers, so these are their own evaluation of their own work life and how it's affected by these AI tools. So, but it seems that it might have an positive effect on job satisfaction, simply from having a very powerful tool when you do your job. And it's a very complicated job for many people, very stressful. But what we see is that to really make use of this technology and to also understand the limitations, I was talking about this, I showed a picture of a parrot. So these models are stochastic parrots. They only give you text, the most reasonable or significant text it can think of. The knowledge can be wrong. So we see that there's a strong need for, let's say, AI literacy. You need to know how to use the tool and its limitations. We also find input that affects positively work-life balance. So a lot of developers use these tools to make mundane tasks easier, to produce boilerplate code, to automate some of the boring, time-consuming part of the job. There's a lot of that in software engineering. Freeing time for being creative, working on the fun parts. So this is what the developers tell us. And we also think it may have a positive impact related to health and wellness through this. So becoming more efficient, taking down a bit of the stress maybe, and increasing the motivation. We also see that it's crafting their job. It's changing the way they work. It might enhance their ability to task completion, to work faster, to reach the goal of producing good code and good functions and features faster, using less energy. So it's changing the job. And we actually found that when developers work in teams or pairs, they found that these tools actually had a positive impact on their social connection. And it's quite common that software developers work in teams and pairs. So it's also a tool for the interaction between people. But we also see that, and we have people telling us that, for instance, juniors tell that the senior is more interested in chatting with the co-pilot than with them. So there might be some reason to be a bit skeptical, and not forget that, after all, people are doing the job. And one way of learning is to work with experienced colleagues. So be aware of the potential negative impact from this. And then from the early experience with the lab that Jan-Henrik was telling about, matching the CVs with the requirements from the customers, it might actually also give you some insight into how your workforce could be trained to better match the need in the market. So it gives you some insight to what do your people know, your people know, and what is the competency they really need to succeed. And that's a really hard task to do manually. And also, of course, which is the core idea, is you might be better at matching the right competency with the right job. It's about job crafting. I could also have connected it with work satisfaction and themes like that. So we believe that if your competency matches the tasks you're given, you might be more satisfied than the other way around. And the last one is, and these are early work, it's about having assistance on how to make sure that you are compliant with the regulations. That's also very complex. Can be a lot of unstructured data, and these tools can help you. Cannot automate it, but it can help you. Okay, so does this make sense? So, I mean, we haven't been touching into all of the KPIs because there are many, and maybe some are dying after this meeting, I don't know. But this is, it's a lot of, it's some interpretation from us. But, we thought it would be cool to see it in the map. And as you see, we haven't studied the lower parts very much, but we could. Depends on the studies we design. Okay, so to summarize, we see that this technology and the early experience, definitely it's relevant for, it's a human-centric technology. It might augment human capabilities rather replacing them. So that's kind of a good signal. and it enables people to be more creative. So yes, it aligns well with part of the focus in Industry 5.0. It might augment their capabilities, being more productive. I think that's also relevant. It's about elevating workers' capabilities. So some interesting findings there. And also, and this might be surprising, but it's also related with the emotional well-being in the workplace. And it's about the excitement I was talking about. So we have developers telling us about being excited. And again, it aligns well with Industry 5.0. And but what they tell us is that when it comes to ethics and privacy, there's a lot of concerns. So, and the developers, I would say, they were well behaved. So they were very careful about what type of information putting into, for instance, ChatGPT, because ChatGPT lives in a box in California. You know, there might be data we have that we shouldn't share with the guys creating these tools. So there's a lot of uncertainty about how to deal with this. So it's an ethical side of this. It's good to be aware of that. And the final part is about collaboration and socialization. And here we find kind of mixed signals. It can enhance and improve collaboration, but it can also threaten it. We don't know yet, how this works together. We don't know yet how it would develop over time. But it's a very relevant topic, I think, within Industry 5.0. And that was kind of the last point in the summary. Okay, thank you.